everything you wanted to know about scientific notation, but were scared to ask. Do we have to go over what scientific notation is? Who's done scientific notation?
Yeah.
Let's review, shall we? Just do this all day. Scientific notation, kids. Scientific notation is a way to write very large or very small numbers. If you remember right, let's say I have this number, 1,300,000. In scientific notation, that would be, Kayleen Shellhammer, what?
1.3 times 10 to the 6th power.
Times 10 to the 6th power. Remember, the decimal starts here. You want a number between 1 and 10. So I move it. Move, 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 move. 6 places, so it becomes 1.3 times 10 to the 6th. Okay? If I was multiplying that times 5 million, okay, what is 5 million in scientific notation? Somebody else here. David?
5 times 0 times 10 to the 6th power.
Okay, and you didn't. I don't really need that decimal point there. I just put it there because I was thinking that. Now here's the deal. The reason why scientific notation is used is because it makes calculating relatively easy. If I asked you to actually do this problem, and you were supposed to multiply 1,300,000 times 5 million, there is just an incredible amount of zeros to do there, and blah 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 blah. I mean, I don't know how you do it or whatever you do it or whatever. I don't even want to do it because there's too many zeros that would make me all messed up. Okay, so here's what we do, and this is what it looks like. I have this. I have 1.3 times 10 to the 6th times 5 times 10 to the 6th. That's how it looks like. Same problem, just written out in scientific notation form. Okay? Here are the simple steps. It doesn't get any easier than this. Step number 1 is you multiply. I don't know why it's not ready. Multiply the left sides. In other words, I multiply 1.3 times 5. You might have to do that to the side if you can't do it in your head. I don't really care if you do it in your head, but it is 6.5. Correct? You write down the times 10. And then step 3 is you multiply the right sides. Now, and here's where you have to be careful because this is not exactly as logical as you might think. 10 to the 6th times 10 to the 6th. What is 10 to the 6th power times 10 to the 6th power? You have 6 tens times themselves times another 6 tens times themselves. A lot of people want to go and say that's 10 to the 36th power, but it does not. Remember, when you have the same bases with exponents, what do you do with the exponents, Brooke? You add them. This is 6.5 times 10 to the 12th. Okay, that's where you have to be very careful with that. Which means if I was actually writing it out long form, I would have, move it over here and then have 11 more zeros after it, which is what I would have got had I written it out like this and tried to do it. It's just, this is by far a much easier way to keep all your zeros straight and all those extra digits and blah, 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 blah straight. Now, lest you think that is the most difficult of it, there's some small little quirky things we have to do. Take a look at this. What if I have 6 times 10 to the 4th power, and I'm multiplying that by 5 times 10 to the 8th power? Make sure I catch these all right. Do they give us negative exponents? They don't. Good. I don't believe. Okay, so what do I get? You probably would know here. Caitlin Stritzel, 5 times 6 multiplying the lefts is
30.
30. Multiplying the rights, 10 to the 4th times 10 to the 8th is, Julia? 10 to the 4th times 10 to the 8th is 10 to the 12th. Okay, now here's the unfortunate thing that happens that you have to address. My answer is not in scientific notation. Why? Somebody want to tell me why? Alex, why? The rule of scientific notation is that the number has to be between 1 and 10, and 30 is not. So you got to do a little change in here. And again, this is something that doesn't always make sense here, which means the decimal starts here. To get it between 1 and 10, I have to move it here. So it is now 3 or 3.0. It doesn't matter. You don't have to put that times 10. But you can't just change this and think that this isn't going to change. Okay? I moved the decimal one place, which means 12 is going to change by 1. So it's either going to be a 13 or an 11. And the way I think about it is this. You have to think about it like a little balance or whatever. If I make this smaller, I have to make this bigger. And this will actually be 10 to the 13th power. Okay, and maybe we should do a couple of those. What happens if I get 75 times 10 to the 9th power? And I say write that in scientific notation. What would that be, Logan?
Actually, I don't understand how you get
6 times 5. Multiply the lefts together to get this number. Multiply the rights together to get that number. 7.75 times 10 to the 9th is, David?
7.5 times 10 to the 10th.
Times 10 to the 10th. Now what about this? What if I had 0.0032 times 10 to the 15th power? I need to move the decimal here so it's a number between 1 and 10, so that would put it where, Grace Watson? Okay, so I have to move this 3 places here. It becomes 3.2 times 10, and again, you have to think about this. I moved the decimal 3 places, so this 15 is either going to go up by 3 or down by 3. Think about it like balancing out. I made this number 3 bigger, so I have to make this one 3 smaller, and that becomes 10 to the 12th. How about this one? What if I had 3,820 times 10 to the 10th power? In scientific notation, that would be Nuzo, what would it be? First of all, where would the decimal go to give me a number between 1 and 10?
between the 3 and the 8.
So I'm moving it here 1.3 places. I get 3.82. What's going to happen to my exponent? It's going to, I moved it 3 places, so I'm either going to make it 3 bigger or 3 smaller. I'm going to do what, Belle? Got to balance out. I made this 3 smaller, so I make that 3 bigger, which is
10 to the 13th power.
13th power. Got that? That's kind of the big chink in all this. Now, we didn't cover this. Not only do we have to be able to do addition and subtraction, we have to be able to do, not only do we have to be able to do multiplication, we have to be able to do division. So this is what a division problem would look like. 3.6 times 10 to the 10th over 1.2 times 10 to the 8th. You can probably guess when I'm going to say how to do this because it's very similar to multiplication. You do the same thing. You need to divide the left side. Anybody want to help me out on what 3.6 divided by 1.2 is? Should be able to kind of do that. Stupert? 3. Write down your times 10. Now, what do you suppose, in thinking about division is opposite of multiplication, what do you do with the exponents of 10? When we multiplied, we added them together. When we divide, Ryan, you?
Subtract.
Right, and you subtract the bottom from the top, so it's 10 minus 8. So exponents get subtracted. So I end up with 3 times 10 to the second power. Right out of the book, here's one. 3 times, does somebody have a question? 3 times 10 to the, does somebody have a question? Brooke? How did I get what 3? This? If I take, Brooke, if I take 3.6 and divide it by 1.2, with the decimal, it's going to be 3. 12 is the 36 3 times. This one will be a little clearer. 8 times 10 to the 4th. Okay, this one you're probably actually going to have to do the work on, because unless you know what 3/8 is as a decimal, which you might, I'm going to have to divide 8 into 3. 8 goes into 3. Let's see, 8 goes into 30, how many times? 3 times, which is 24. 8 goes into 60, 7 times, which is 56. 8 goes into 40, 5 times. This is what I get when I divide 8 into 3. I get 0.3, or I get 0.375 times 10. What do I get for my exponent of 10 there? Division is subtraction, Cabron, so I get a 9 to the 4, subtract.
You, it needs to be a number between 1 and 10.
I'm not there yet. Thank you very much. Now, Ryan says that is no good because it needs to be a number between 1 and 10. So Noah says I'm going to do what? You need to make this a number between 1 and 10, so I have to. No, I haven't done it yet. I'm getting to that. Where do I put the decimal here? Make it a number between 1 and 10.
Between the 3 and 6.
Right, so I need to move this here and make it 3.75. And then the exponent, here's where a lot of people just go wrong. What do I get from my exponent? I made this one bigger, so this becomes one smaller, and it's 10 to the 4th power. Why do I have to pride with cheering or clapping? You kind of think that that'll get you there. Let me give you one to do. Here's one, I think. You do this one for me. 1.2 times 10 to the 7th over 3.0 times 10 to the 3rd. 3.0 times 10 to the 3rd. Give me that and answer it please in scientific notation. Stop raising your head so fast. Everybody feel relatively confident with their answer? Cameron A, what do you say?
2.5 times 10 to the 4th.
2.5? You divide 3 into 12. 3.0 into 1.2. It's always bottom and the top. Which means you'd have to move the decimal, How many times does 3 go into 12? Did I do that right? I don't know. 30 into 12. Stop. Stop. Hold on a second. Let me do that again. Yeah. 30 doesn't go into 12, so you have to put the decimal there and add the 0. 30 goes into 120. 0.4 times, right? And times 10 to what power? 3 from 7 is 4. Not in scientific notation, so Madison, I have to,
Move the decimal.
which makes it 10 to the, I made this one bigger, so I have to make that one smaller, 10 to the 30. Now, could you imagine, people, this would be the way the division problem would work without scientific notation. It would be this, 1, 2, 0, 0, 0, 0, 0, 0. Is that right? 1, 2, 3, 4, 5, 6, 7. And you're dividing that by 3, 1, 2, 3. I mean, yes, I think it's not that hard to do, but trying to keep all these zeros in place and figuring out where the numbers go there just would be, I mean, you'll get 4,000 for an answer, but it's certainly a lot less complicated with all the zeros and all that stuff there. Logan?
Yeah, we're gonna ask us to do that in the standard notation.
Yeah, oh, it'll ask, sometimes it'll ask you to write your answer in standard notation. Yeah, it'll do that, they do that every now and